Hello, Algebra 2. This is our second video for the week of May 11th through the 15th, week 5 of our distance learning. Exciting times. We're making the best of it. Anyway, I hope you're doing well. Please don't forget Google Class. We have Google Meets a couple times at least a week, and I'm here just sitting all by myself. So feel free to stop by, ask me a question, or tell me a joke, or, just say hi. I'm here for you. Let me know. Okay, we're going to continue our 9.4 Part 1 lesson. Last video, we were investigating what the graphs of sine and cosine look like. And now we're actually going to dive into graphing sine and cosine. So here we go. Hopefully you had a chance to either download the notes, print them, or you can just use some graph paper and draw along with us as we go. But definitely you should be trying to physically graph these, not using a graphing calculator, but actually you need to know how to graph these points and how to translate the points. So please don't rely on a graphing calculator. It will not help you, or it will hinder your progress in the future. So again, use your own paper or print this off and graph along with us. So when we're graphing our sine and cosine functions, remember with these, the points in this table on the notes came from the unit circle. And we looked at, these are just looking at our key four corners, I guess you would say, of the circle. And those, we're going to actually use 5 key points when we're graphing and translating our graphs. So the 5 key points that we're going to use in the table here are these guys, where our x, or the angle measure, is the 0, pi over 2, pi, 3 pi over 2, and 2 pi. So those are kind of on the x, those are on the x and y axes, where the circle intersects the x and y axes. So this table shows those 5 key points for our sine and for our cosine. And we always use those 5 key points, and then we're just going to translate everything. Some other good information that we're going to be using and thinking about when we graph is in this box right here where we have our amplitude. And we talked about that in the last video. And that's the half the distance between the highest and the lowest point. And that's always a positive number because it's distance. That's why there's absolute values around the a value. That a value can be found in the front of our equation. So this a is in front. That's our vertical stretch or shrink. It's going to see how high it goes up and how high it goes down. And then the other important thing that we're going to be focusing on is the period. That's the length of the horizontal distance, or length of one cycle. And so we use whatever number is multiplied by the x, so because that's our horizontal stretch or shrink. That'll change our period length, or the length of one cycle, horizontal length of one cycle. And then the other steps to keep in mind provided in these notes are how do we go about graphing. And so we kind of outline these steps for you here. The first step is you're going to look for those key points, the amplitude and the period and the shift. And then step 2, we're going to draw on our midline. And then we're going to use our 5 key points, graph it, and then translate those. And then we're going to draw the curve through our points to get our curvy graph, or our sinusoid is what it's called. Okay, so enough of those. Let's get going. Okay, first example here, we're asked to identify the amplitude and the period of our function. So again, the amplitude, excuse me, got some allergies going on here. The amplitude is the number in front of our sine, cosine, or tangent. And so in this case, our amplitude equals 2. And again, that's half the distance between the top and the maximum point and the minimum point. And then the period, that's always 2 pi divided by whatever our b value is. And the b value is the number multiplied by the x. And since there is a number, we don't see a number there, that would be 1. So our period, or horizontal distance of one cycle, is just 2 pi. And then we look for whether or not there's a shift. And the shift is any number that's added or subtracted at the end of our sine, cosine, or tangent. In this case, we don't have any number out there, so there's no horizontal shift. Then our midline, we want to identify as well. So that midline is a line that goes right through the middle, and it's always y equals whatever numbers added or subtracted. And there is no number added or subtracted, or we could say it's 0. So our midline is 0, so that's the line that goes right through the middle of our graph. And then it doesn't hurt to remember that our vertical shift is 2. Or stretch, dang it, sorry, vertical stretch. That doesn't make sense, there is no shift on this. Vertical stretch is 2. Okay, so, excuse me. I'm going to start by graphing the parent, and I'm going to use red for my parent color. So I'm going to graph my parent to start with, and I'm using that table up top with those 5 key points for the sine of x. And so my first point is 0, 0, and then at pi over 2, we go to 1. And then at pi, we go back to 0. And at 3 pi over 2, we go to -1. And then at 2 pi, we go back to 0. So that is the parent. So that's what a sine, one cycle of a sine function looks like. And then if we take that parent and we stretch vertically, our parent stretched by 2, the points on the x-axis are going to stay stuck there. But the maximum is going to double. So it's at 1 right now, height of 1. So and we're stretching that double. So that's going to stretch to 2. And then we have a minimum at -1, and we're going to stretch that to -2. And the midline, I forgot to draw in my midline, is at y equals 0. That's my x-axis. That's my midline. And so now I've got my 5 key points. I've got my midline. So now I can draw in my, it's supposed to not be, it's supposed to be smooth. A smooth curve. I don't know why I can't do that. Okay. We're going to ignore my icky curve and move on to the next page of notes. Excuse me again. Okay, we're going to continue. This time we're going to focus on a cosine. So switch into a cosine instead of a sine. And we go through all the same steps. We think about first what's our amplitude. And that's half the distance between the top and the bottom, the highest and the lowest. And that's the A value. So in this case, our A value is 1. Because it hasn't been stretched or shrunk vertically. Then we're going to think about what the period is. That's the length of one horizontal cycle. And it's always 2 pi divided by our b value. And this time our b value is 2. So that's the number that's multiplied by the x. So 2 pi divided by 2 is just going to equal pi. So that's how long one cycle is going to be. So we're going to kind of end our cycle at pi instead of 2 pi. Then we think about the vertical shift, and there is no vertical shift here because there's no number added or subtracted to the end of our equation. Then we think about our midline, and again, that's using the vertical shift as well. So what number is added or subtracted to the equation? No number that we see, so we know our midline is going to be the x-axis, or y equals 0. And then the last thing is to think about the horizontal shrink. And in this case, our horizontal shrink is 1/2, because there's a 2 multiplied by our x. So remember, that's anything with the x is a horizontal transformation. And in this case, we have a 2 there. And remember, any horizontal transformation does the opposite of what we think is going to happen. So instead of horizontally stretching by 2, it's really shrinking half. And we didn't cover horizontal stretches and shrinks very much in our other function. So this is going to be a little bit of a new concept for some of us. Okay, then we go. We start with our 5 key points of our parent function. So I'm going to write that in red. That parent function is the cosine of x. So we go back to our table on the previous page and look at the 5 key points that I highlighted for cosine. So at 0, we start up at 1, because a cosine starts high, goes down low, and goes back up high, so it's that part of the sinusoid. The cosine of pi over 2 is 0. That's where it crosses. The cosine of pi is -1. And then the cosine of 3 pi over 2 goes back to 0. And then cosine of 2 pi is at 1. So that's our parent. That's what a cosine looks like. And then we're going to take that parent and we're going to transform it into the cosine of 2x. So our amplitude is going to stay the same. We're not vertically stretching or shrinking. But our period, we are ending at pi. So I know instead of ending at 2 pi, my period's going to be here at pi. So it's half. It's like I'm pushing everything to the left, or shrinking it to the left by half. So instead of ending at 2 pi, I'm going to end at pi. And then I'm starting still at 0 and 1. So I could just shrink everything in half. So my lowest point, instead of being at pi, is going to be down here at pi over 2. And then my other 2 points of my 5 points have to be where I'm crossing the x-axis. So here's my same valley shape of a cosine, but everything's been shrunk horizontally by a half. And I, again, forgot my midline. I always forget it when it's the x-axis because there's no shifting up or down. So that is a little bit tricky that'll be tricky for some people. Definitely don't forget to practice. Okay, and we're moving on to the next example, where we've got the sine of x and then -3. Okay, same process. Oh, yeah, no, I did. Okay. I was thinking I forgot to describe the transformation, but I didn't. I remembered, yay. Amplitude, and that's the number in front of my sine. And I don't see a number there, so I know my amplitude is 1. That's going to be my highest and lowest. The difference between my highest and lowest. The period is always 2 pi divided by b. And b is the number that's multiplied by my x. And in this case, I don't see a number multiplied by x, so I know that equals 1. So my period is going to be 2 pi this time. So not anything shrunk horizontally. But the -3 at the end now tells me I do have a vertical shift, and it's going down 3. So that's where my transformation is happening. My midline, then since my graph is going to be shifted down 3, that changes my midline now to y equals -3. So finally something different than the x-axis. And so my transformation, I would say it's a vertical shift. Down 3. My parent is, again, y equals the sine of x. Excuse me. So I'm going to graph my parent first, and that's using that table again. So my 5 key points is 0, 0, and then sine goes up to 1 at pi over 2, back to 0 at pi, down to -1 at 3 pi over 2, and then ends my cycle at 2 pi. So that's the parent. And yes, you should graph that. You're learning how to graph these things, so yes, you should be doing that. I'm going to definitely draw my midline this time at y equals -3. That will help guide me to remember how everything should look when I shift it all down 3. So that's my big move this time, is to take each point and shift it down 3. So at 0, 0, that's going to become 0, -3. At pi over 2, 1, I'm going to shift that down 3 to pi over 2, -2. And then pi, -3. 3 pi over 2 is at -4. And 2 pi is going to be back at -3. So you take each one of your points and shift them down 3. And then try to draw a curved, smooth line. And that's our y equals sine of x minus 3. I'm going to keep going. Just remember, you can pause if you need a little extra time or rewind and all that fun stuff. Okay, now we've got y equals 3 times the cosine of x plus 2. So it'll be a little extra fun on this one. We're going to start by finding our amplitude, and this is time it's 3 because of the 3 multiplied in front of the cosine. So that's going to be half the distance between the highest and the lowest point. The period is always 2 pi divided by b, and in this case our b is a 1 because I don't see any number multiplied by my x. So just 2 pi. I can see there's a shift up 2 because of the 2 added on at the end. And then my midline then is going to change as well to y equals 2 because of that shift up 2. And so my transformation is a vertical shift up 2 and a vertical stretch by 3. Can you read that? Nope. A vertical stretch by 3 is what that should have said. Given up. Parent is y equals the cosine of x. I'm going to graph that first. Yes, you should graph it first. So cosine always starts up high, so 0 at 1, and then it goes to 0 at pi over 2, and then down to -1 at pi, back to 0 at 3 pi over 2, and back up to 1 at 2 pi. You should practice that over and over. It will help you. So there's our parent. I'm going to draw in my midline at y equals 2. Oops, that helps, again, guide me to remember what some of the transformation that's taking place. So there's my y equals 2 line. So all those points are going to be shifted. And then I'm also stretching. So my amplitude is 3 instead of 1, like the parent has an amplitude of 1. So when we are graphing a vertical stretch or shrink like this and a transformation, it's easier and less confusing if you follow the steps of first doing your stretch or shrink. So I'm going to write that over on this side. First, stretch or shrink. And then in the future, when we do reflections, you would do that as well. And then the second thing, then you're going to shift up or down. Oh. So first stretch or shrink, then shift up or down. Okay, so I'm going to go with a different color here to show my shift up, or my stretch, my stretch. So I'm vertically stretching by 3. So the points that are on the x-axis are stuck there, but my maximums are going to stretch 3 times higher. And my minimum of -1 is going to shift, or stretch, geez, oh Pete, multiply by 3, so it'll be 3 times lower. So that's my stretching part. Now to get my final graph, I'm going to shift each one of those points up 2. So these yellow points are now going to be shifting up 2. So that point at the 0, 3 shifts up to 5, 0, 5. The point on the x-axis at pi over 2, 0 is going to shift to my midline, which makes sense, right? Because now my midline is not the x-axis. My minimum point here at pi -3 is going to shift up. 1, 2, 3. Oh, up 2, sorry. Good gosh. Next point is going to go up 2. And my last point goes up 2. So then that is my new function, which is 3 times the cosine of x plus 2. And again, hopefully your graphs are smoother than my stylusy looking graph. Okay, again, those are a little bit tougher to think through, so be careful. Make sure that you are, please practice. Check your answers on big ideas. That helps you, gives you immediate feedback. There's videos you can click on. You can click on Get Help. If you need help, please come to the Google Meets if you have questions. Again, not necessarily easy stuff to try to learn on your own. So you have lots of options to get help when you need it. Please, I'm begging you to do that. All right. I miss you guys. Notice that there's a homework, yay. They're down at the bottom, and on the next page we provided some graphs. They're supposed to look like 5 graphs because there's 5 problems that should be graphed. You're of course welcome to use your own graph paper and draw your graphs on there. You should not be using lined notebook paper for graphs, especially these kind of graphs. So definitely use graph paper, please. And then finally, we provided the copies of the book if you didn't have a chance to look at the book online. All right. Hope you're all doing well. Miss you. Hopefully, yes, see your face on Google Meet. Bye.